So let's continue on. Another recent probe found galaxies inconsistent with the theory of dark matter, which posits this hypothetical substance to be everywhere. But according to the latest measurements, it is not, suggesting the theory needs to be re-examined. Well, I think we've definitely covered that, haven't we, about the dark matter and how nonsensical it actually is. But it's good to know that at least mainstream is starting to catch on to this. So let's continue on. It's perhaps worth stopping to ask why astrophysicists hypothesize dark matter to be everywhere in the universe. The answer lies in a peculiar feature of cosmological physics that is not often remarked. For a crucial function of theories such as dark matter, dark energy, and inflation, which each in its own way is tied to the Big Bang paradigm, is not to describe known empirical phenomena, but rather to maintain the mathematical coherence of the framework itself while accounting for discrepant observations. So in other words, guys, they're saying that, just like Walt Thornhill said a long time ago, the object is to make the math work out, right? Damn the actual results. Just fit it into the math envelope. That's all that matters. Okay, so fundamentally, they are names for something that must exist insofar as the framework is assumed to be universally valid, and assumed being the big key word there. Each new discrepancy between observation and theory can, of course, in and of itself be considered an exciting promise of more research, a progressive refinement towards the truth. But when it adds up, it could also suggest a more confounding problem that is not resolved by tweaking parameters or adding new variables. Uh-oh, mass running out.
Yeah, when you start with an incorrect foundation, then you may tell people that you're getting closer and closer to the truth, but you're just getting further and further away, truly.
Yeah, exactly right. All right, consider the context of the problem and its history. As a mathematically driven science, cosmological physics is usually thought to be extremely precise. Yeah, right. But the cosmos is unlike any scientific subject matter on Earth. A theory of the entire universe based on our own tiny neighborhood as the only known sample of it requires a lot of simplifying assumptions. And boy, that's exactly what they do. That's why cosmology, astronomy, astrophysics are all pseudosciences, because it is nothing but assumption after assumption compounded by mathematical formula and mathematical theory, etc., etc.
So this has to do with the orbit of the Earth around the sun. So let's say that you have the sun here in the center.
Okay. Anyway, when these assumptions are multiplied and stretched across vast distances, the potential for error increases. And this is further compounded by our very limited means of testing. Yeah, limited would be an understatement. Historically,
it's
Newton's...
a fact. They know everything, Bob. They sent out the Challenger and all the Explorer satellites to the outer stretches of the universe. They know it all.
That's right. And they can send back signals that are 1/10 trillionth of a billionth of a picowatt. Okay, Einstein's general relativity framework provided an extended and more precise reach beyond the furthest reaches of our own galaxy, but just how far could it go? The Big Bang paradigm that emerged in the mid-20th century effectively stretches the model's validity to a kind of infinity. Defined either as the boundary of the radius of the universe, calculated at 46 billion light years, or in terms of the beginning of time.
I just have to stop for a second. It says this giant stretch is based on a few concrete discoveries, such as Edwin Hubble's observation that the universe appears to be expanding.
Yeah, that's so really concrete.
Concrete discovery because something appears to be doing something. That's funny. All right, go ahead. Sorry, I won't interrupt anymore.
That's okay. Love the commentary. Okay, but considering the scale involved, these limited observations have had an outsized influence on cosmological theory. Boy, that's an understatement. It is, of course, entirely plausible that the validity of general relativity breaks down much closer to our own home than at the edge of the hypothetical end of the universe. And if that were the case, today's multi-layered theoretical edifice of the Big Bang paradigm would turn out to be a confusing mix of fictional beasts invented to uphold the model along with empirically valid variables, mutually reliant on each other to the point of making it impossible to sort science from fiction.
Jeez. I keep having to check the URL to make sure we're not at the Onion. Sounds like an Onion article. It really does. Doesn't sound like something from Scientific American, but they're dead on.
They are. They're nuts on. They are telling it like it is.